Okay, so we're starting on week 5 lecture notes. Okay, and so these ones are in your book. I'll be covering sections 5.2 and 6.2, which basically deals with scientific notation and ratios. Okay, so something nice, not too crazy. All right, so let's go ahead and get started on that. So let's look at the first question. It says here the cost for 2.8 pounds of shrimp is $19.46. Find the unit price in dollars per pound. If necessary, round your answers to the nearest cent. And the second part here is asking write 5 times 10 to the third in standard notation. Okay, so the first one says the cost for 2.8 pounds of shrimp is $19.46. Again, find the unit price in dollars per pound. So all we have to do for this one is we just take the total cost there, which is $19.46, and then divide it by 2.8, correct? And that gives us $6.95 per pound. So that would be the unit price. Okay. The second one here is this is in scientific notation, okay, and we want it in standard notation. So that means that we shouldn't have no, times 10 to the third, no powers, nothing being raised to. So remember, this is telling me that 10 is written 3 times. So it's going to be 5 times 10 times 10 times 10, okay? Or 5 times 1,000, or 5 times 1,000, which is 5,000, okay? Now, one good thing to remember when we're dealing with converting back from scientific notation, standard notation, is where, how does the decimal work there? So if I have, say, 10 to the 0 power, okay, if I want to, if the power goes down or goes to the right, okay, then the power here will go down. So again, if I move the decimal to the right, okay, the power there will go down. It will move down. If I move the decimal to the left, okay, then the power will go up. Okay, we'll move up. Okay. So in this case, I had 5, right, times 10 to the third, so that's 5.0. I want to raise that times 10 to the third, so that means I'm going to go to the right, so that'd be times 10 to the third, the second, first. So when the power goes down, it goes to the right and makes that bigger. Okay, so that gives us the 5,000. Okay. All right, let's go to the next question. So here it tells us how to the procedure for writing a number in scientific notation. So move the decimal so that there is only one non-zero number in front of the decimal point, and write this number times the corresponding power of 10. Okay, so in this case, so if I had 12,000, all right, so my decimal will be right here, right? So if I go back to my previous slide, if I move the decimal to the left, if I go this direction, the power is going to go up. So in this case, so it'll be times 10 to the first, second, third, fourth, and that's why we have times 10 to the fourth. Okay, so the key part here is that there can be one non-zero in number in front of the decimal point. So it's talking about this right here. It cannot be 0.2. Okay, it has to be a number bigger than 0. That's what it says, one non-zero. So like 1.2, 2.2. Okay, but it can never be a 0 in the front. It has to be a number 1 or above. Okay, so um So if there's a 0 there, that means you need to move it again. All right. So in order to put in scientific notation. Okay. So that's for this case. All right. Now this one here is procedure for writing a small number in scientific notation. So this one says move the decimal so that there is one non-zero number in front of the decimal point. Write this number times the corresponding power of 10 with the negative exponent. All right, so here is where I'm starting, right? So again, I need to move it um, so that there's only one number in front of that decimal. So the number I want is 2. So I'm going to move it 1, 2, 3 times, okay? So since I moved it 3 times, remember, if it goes to the right, right? If it goes to the right, the power goes down. This power here goes down. So I went 10 to the negative 1, 10 to the negative 2, 10 to the negative 3. So that's where this comes from. Okay. And again, we only have one number in front of that decimal that's not a 0. And this will be in scientific notation going the other direction. Okay. All right. So why don't you guys try one? This one over here. This. So again, these ones we want to write in scientific. Okay, so again, these ones we want to write in scientific notation. So if I move to the left, remember the power goes up. So, and I want to move it so that there's only one number in front of the decimal. So I move it once, twice. So I have 7.843 times 10. So that I move it to the left and the power goes up. So that'll be times 10 to the second power. This one here, I'm going to move to the right, so that means the power is going to go down. So I have 1, 2, 3, 4. And again, I want one number in front of the decimal. This decimal is before that number, so I have to move it one more time. So that gives me 8.0 times 10 to the negative 5. Or you can just write 8 times 10 to the negative 5. And then the same thing for this one. I'm going to move it 1, 2, 3, 4, 5, 6. So that gives me 8.739 times 10 to the negative 6 power. Okay. Okay, I'm going to skip this one for right now and come back to it later. I want to focus on multiplying and dividing scientific notation. So let's look at this one. So this is, I want to multiply this scientific notation. And so just to kind of review your memory here. So for example, the rule is if let's say I have x to the third times x squared, right? So if we have the same base, I can just add the powers. So that would be 3 plus 2, which gives me x to the fifth power. All right. So the rule is x a times x to the b is equal to x to the a plus b. You just add the powers. All right, so that's what I'm going to do here. But before we do that, I want to match the numbers that have no powers and then match the ones with powers. So in this case, I'm going to match these two numbers here, okay, because they don't have any power. So that's going to be 6 times 4.7. So I'm going to multiply those together, okay. And then I'm going to match the ones with power. So that's going to be times 10 to the fifth times that 10 to the ninth power. Okay. Then I just put this in the calculator. So when I put this in the calculator, 6 times 4.7 is going to give me 28.2. And this one here, right, I'm just going to apply the rule, right? The rule says, hey, if you have the same base, I can just add the powers. So that's going to be 5 plus 9, which is 14. Okay. So I'm going to have times 10 to the 14th power. Okay. Now I have to be careful because it says write your answer in scientific notation. This is not scientific notation. Okay. Why? Because I have two numbers in front of the decimal. So what I need to do is I need to move this decimal here and move it to the left. So when I do that, I get 2.82. times 10. Again, when I move it to the left, the power goes up. Okay, so 2.82 times 10 to the 15th power, and then there's our final answer. All right, so again, we're going to follow the same format as we did before. We're going to match the ones with no powers and then match the ones with powers. Okay, so in this case, I'll have 9 times 5.4 times that by 10 to the 8 times 10 to the negative 4. Okay, so again, when we have the same base, we just add the power. So that's going to be 8 plus negative 4, which gives us a positive 4. All right, so here we're going to have 9 times 5.4 is 48.6, and then times 10 to the 4th power. Okay. Again, this is not in scientific notation because there's 2 numbers in front of that decimal, so I need to move it one more to the left. That gives me 4.86 times 10. And then remember, when we move it to the left, the power goes up. So our final answer here is 4.86 times 10 to the 5th power. All right, so this one we're going to be dividing in scientific notation. Okay, so again, to jog your memory here, so let's say we have x to the 5th power divided by x to the 3rd. So if I wanted to divide this, all I need to do is I need to bring the x to the 3rd to the top, okay? Or in this case, when I'm dividing, I can just subtract the power. So it'll be 5 minus 3, okay? So, but technically, it should be x times to the 5th raised to x to the negative 3, and I write 5 minus 3, okay? Which gives us x squared, all right? So that's what I would do here. All right, so again, so for this one, again, I want to match the ones that have no powers and then match the ones with powers. So in this case, I'll have 9 divided by 5 times that by 10 to the 5th divided by 10 squared. So 9 divided by 5 is going to give me 1.8. And then 10 to the 5th divided by 10 squared. So again, since I'm dividing, I just subtract the powers. So that's going to give us 3. Okay. So that's going to be 10 to the 3rd power. Okay, and then there's my answer. Right, because again, it wants it in scientific notation. Right, so what you guys try at the bottom there? See what you get? Well, all right, so again, we're dividing in scientific notation. So again, what we want to do is we want to match the ones with no powers and then match the ones with powers. So these ones don't have any powers, so I'm going to put them together. So 7.2 divided by 1.6, okay? Times that by this one here, 10 to the 6 over 10 to the negative 7. All right, so 7.2 divided by 1.6 is going to give me 4.5. And then 10 to the 6 divided by negative 7. So again, remember, when we raise it, right, when we raise it up, okay, we're going to subtract, but we already have a negative 7 there, okay? So we're going to subtract, but we got to keep the negative 7, so we have another negative there. So in reality, we're going to have 10 to the 6, and then we're going to add those powers, okay? So again, when we divide, we subtract the powers, but we have an extra negative there, so 2 negatives become a positive, all right? So that gives me 10 to the 13th power. Okay, so in this case, I get 4.5 times 10 to the 13th power.